Okay, right, we are now going to look at bounds in context, okay? Now these only appear really in the higher tier, and they could be anywhere in your paper. If it's something like question 1, it will be sort of near the beginning. It's probably only a grade 5. If it's a bit trickier, it could be right at the end, okay? We're talking right at the very last question. There could be a question involving bounds, okay? Now sometimes they're easy to spot because they say the word bound in them, other times they're not so easy, okay? But the minute you see the word bound, you need to be working out the bounds of all of the values you've been given, okay? And if you do that, you are going to get some marks, okay? It might be 1 mark, it might be 2 marks, depending on where the question is and how many marks it's worth, all right? But it's worth doing. So here we have a field, apparently, a rectangular field. It's 14.3 metres that way. That is correct to 1 decimal place. And it's 6.3 metres wide. That is correct to 2 significant figures. And it asks you to calculate the upper bound for the area of the field. Okay? Now, I don't care what it asks you. You do the bounds first. So let's take the value 14.3. And we want to do the upper and lower bound. So if we go 1 decimal place higher, that's 14.4. 1 decimal place lower, 14.2. Halfway between them, so we get the lower bound is 14.25 and the upper bound is 14.35. If that is not making sense, you need to go and look at the bounds video again and practice calculating bounds. Okay, it's assumed knowledge in this video. Okay, the width is 6.3 meters, so we need to go, and that's 2 sig fig, so we need to go 2 sig fig higher, so that would be 6.4, and 2 sig fig lower is 6.2. Halfway between for your lower bound is 6.25. Halfway between for your upper bound is 6.35. Okay, you have got some marks. If you do nothing else, you have got some marks. All right. Now it asks you to calculate the upper bound for the area of the field. Okay. Well, we know the area of a rectangle is base times width, length times height, whatever you want to call it. Okay. Base times width, length times height. So in order to get the upper bound for area, I'm going to need to do, so I want the area to be the highest it could possibly be. That's what it's saying. Calculate the upper bound for the area. So how can I get the area to be the highest it can possibly be? Well, if I multiply the highest of the length and the highest of the width, and the highest of the base and the highest of the width, that will give me the highest area. Okay, so I'm going to do 14.35 times 6.35. Now, it is absolutely vital that you write down what you are doing. Okay, that is how you're going to get marks. So you're doing the upper bound of the length times the upper bound of the width. Okay, you must write this calculation in. If not, you will not get the marks. Okay, then you can use that on it. This will be in a calculator paper, obviously. 14.35 times 6.35. Now, again, you must write down all the numbers, okay? And do not round it unless it tells you to. Because if you did the 2 lower bounds, let's just experiment. If we did the 2 lower bounds, so 14.25 times 6.25, and you got 89, we could round them both to say 1 significant figure, and they'd be the same number. That would be 90, that would be 90. Okay, so you must write all your numbers down. Okay, right. The key bit there is thinking about what gives us our upper bound for area. Okay, let's go on to the next one. So you've got a formula here. We have no idea what it's talking about, but we know it's a formula. We've got A plus B over C is P. We've been given what A, B, and C are, and they have all been rounded. Okay, it's asking us to calculate the lower bound of P. The minute you see bound, you just start cracking on with all the bounds. So A, we've got 4.8. We need to go 1 decimal place higher and 1 decimal place lower. Our lower bound is going to be 4.75 and our upper bound is going to be 4.85. Okay, then we take the number B. So we've got 15 to the nearest integer, so we go 1 integer higher, 1 integer lower, halfway between. So our lower bound is 14.5 and our upper bound is 15.5. Okay, then we go to C. I'm not sure why I've only underlined my lower bound. We've got 4.38 to 3 sig fig, so we need to go one higher to 3 sig fig and one lower. Then halfway between, so our lower bound is going to be 4.375 and our upper bound is going to be 4.385. Okay, now it wants the lower bound of P. So, I'll split my page in half. I want the lower bound, the LB, of P. How am I going to get this formula, to be the lowest it could possibly be? Well, if I do the lowest and I add the lowest, that will give me the lowest. So at the top, I need the lower bound of A, and it helps to write down what you're thinking, and the lower bound of B. Okay, so I've got to do the lower plus the lower. Now, what do I need to divide it by in order to get the lowest possible value of P? What do I need to find the lowest possible value by to get the lowest value of P? Well, I need to think of it, you're sharing the smallest pizza between the most people. That will give you the smallest amount of pizza. So I need to divide it by the upper bound of C. Okay, so to get my lower bound of P, I've got to do my lower bound of A, which is 4.75, plus my lower bound of B, which is 14.5, divided by my highest possible value of C, so my upper bound of C, which is 4.385. Okay, it is absolutely vital that you write down this calculation. This calculation carries all your marks. Okay, this is important, these are important. That is really important. Okay, so we can just chuck that in our calculator. 4.75 plus 14.5 divided by 4.385. And again, you must write down all of the digits. Okay, because if you did the lower one, you might have something that's just slightly different down here. The upper bound, sorry. Okay, so it's really important. You can round it at the end if you'd like. I'm going to suggest we round it to 3 sig fig. Okay, but if it doesn't ask you to, I wouldn't get too worried about it. Okay? Right, now this is going to be the hardest one. Are you ready? Here we go, this is an exam question. So, V is the square root of A over B. A is 6.4 correct to 2 decimal places, 6.43 sorry. And B is 5.514 correct to 3 decimal places. Work out the value of V to a suitable degree of accuracy. Have we talked about bounds anywhere in this question? No. So you need to recognise that if it is telling you that something has been rounded and is correct to anything, a number of decimal places or a number of significant figures, that is your clue that this is going to be a bounds question. Okay, so the minute you see that, you're thinking, okay, we've got bounds. So let's do the bounds of A and let's do the bounds of B. So A, we've got 6.43 to 2 decimal places. So we want to go 2 decimal places higher and 2 decimal places lower. Halfway between for our lower bound is going to be 6.425. And our upper bound is going to be 6.435. Okay, similarly with B, we've got 5.514 to 3 decimal places, so we've got to go 3 decimal places, 1 higher and 1 lower. Okay, halfway between is going to be 5.5135, so now 4 decimal places, and our upper bound is 5.5145. Okay, now it hasn't asked us to do the highest or the lowest of V. It's just asked us to work out V to a suitable degree of accuracy. So far we've got 1 mark, okay, from doing the bound, maybe 2 if they're feeling generous. Okay, so we need to work out both versions of V. We need to work out the highest that V can be, and we need to work out the lowest that V can be. Okay, so we know we're going to have to square root in both of them, so it's a bit irrelevant that the square root's there. How am I going to get the highest value of V? So how am I going to, when I divide 2 numbers, how am I going to get that to be the biggest possible? Well, I need to do the biggest amount of pizza with the smallest amount of people. So I need to do the upper bound of A divided by the lower bound of B. That will give me my highest value of V. And for my lower value, I need to do the least amount of pizza, so the lower bound of A, divided by the highest number of people. Share it with the highest number of people, upper bound of V. Okay? Right, we then need, we then need to do these calculations. So the upper bound of A, now this again is really important. They're going to give you the marks for putting in these numbers. So 6.435 divided by the lower bound of B, which is 5.5135. And over here, the lower bound of V is going to be the lower bound of A, which is 6.425, divided by the upper bound of B, which is 5.5145. Okay. You then need to pop them into your calculator. Now again, really important, you're obviously putting them into your calculator correctly, but you don't forget the square root sign. That's a common mistake as well, so make sure you put it in exactly as it is. Okay, and you write down the whole answer. So it's 1.080340323. That's the upper bound. On the other side, the lower bound of V is going to be the square root of 6.425 divided by 5.5145, 1.079402689. Okay, so happy days. We've got two values of V. We've got the highest that V could possibly be, and we've got the lowest that V could possibly be. Now the question asks us to give it to a suitable degree of accuracy. That's another hint that it's bounds, if it says something about that. Okay, now if we rounded these to one significant figure, they'd both be 1. If we rounded them to one decimal place, they'd both be 1.1. If we rounded them to 3 decimal places, they'd both be 1.08. If we rounded them to 4 decimal places, this one would be 3 decimal places, sorry. This would be 1.080, and this would be 1.079. So they don't agree. So what you have to do is you have to round them to the same thing so that they both agree. So if we round this to either 2 decimal places or 3 sig fig, because they mean the same thing in this case, they both agree. So that is our suitable value of V, because it's the most decimal places possible, the most numbers possible, but they both still agree. The upper bound and the lower bound both agree is 1.08. Okay, it's not halfway, it's so they both agree.